Ho, 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 Merry Hackmas. Thanks for tuning in. This is day number 9 of the Advent of Cyber 2023 challenge. Today we're going to look at malware analysis. She sells C-sharp shells by the C2 shore. What an interesting title. Having retrieved the deleted version of the malware that allows Tracy McGreedy to control Els remotely, Forensic Blue and his team have started investigating to stop the mind control incident. They are planning to take revenge by analyzing the C2's backend infrastructure based on the malware source code. All right, that sounds interesting. In this task, we're gonna be looking at the foundations of analyzing malware samples safely, the fundamentals of .NET binaries, the DN spy tool for decompiling malware samples written in .NET, and building an essential methodology for analyzing malware source code. Malware handling is dangerous. Always take precautions. As mentioned, handling malware is dangerous because it is software explicitly designed to cause harm, steal information, or compromise the security and functionality of computer systems. Given this, we will introduce the concept of malware sandboxing. So, sandboxing is like a pretend computer that acts like a real one. It's a safe place for experts to test malware to see how it behaves without danger. Having a sandbox environment is essential. It stops experts from running malware on their actual work computers, which can be risky and harmful. So a typical environment setup of my malware sandbox includes network controls, virtualization, monitoring, and logging. We already started the virtual machine. It looks like we're going to be doing static analysis. So static analysis is malware analysis where you don't actually run the malware. You're just looking at the code and try to piece together how it works based on the code that's involved with it. I do not know C sharp. I do know C, Java, and Python and Pascal. All right, these are just code snippets. Yeah, this goes into details about some of the parts of a C sharp program. Here we have a C2 primer. So basically, with this C2 server, the user executes the malware. The malware connects to the C2 server and asks for instructions. The C2 server responds with a set of instructions. The victim executes the instructions. The malware reports back the output to the C2 server, and the attacker can connect to the C2 server and use it to issue and execute commands on the victim computer or server or machine, whatever. Um, So the C2 server can cause the machine to send HTTP requests, do command executions, or sleep and delay. So we're going to decompile a malware sample using this program, dnspy. dnspy is an open source .NET assembly debugger and editor. It is used for reverse engineering .NET applications and analyzing their code. Right, we open dnspy. We're going to open up the file, desktop artifacts. Desktop artifacts. Let's set this up. All files. Open that. Let's expand the tree view a little bit. So it wants us to click on the main function. If you followed along yesterday, some of this may look very familiar, such as the C2 server domain name. All right, so we're going to look over some of this, and looks like we're going to go over these functions a little bit. All right. So the main function is going to be the entry point where the program starts. So we're going to look over that first and kind of get an idea of what this malware is doing. So it's going to retrieve the host name from the computer. It's going to use this string here, the C2 server. It's going to add reg for, I guess, registry or register to the URL. So this URL is going to be this with a slash reg at the end. Data name equals host name. String 2 is program dot posted. Let's see what posted does. Posted is going to send a post request using this user agent content type. All right. So it's going to send a post request with the computer's username. Count is 15,000. It's going to call program.sleeper. It's going to call program.sleeper. And it's going to sleep for 15,000, which for a lot of timer functions and programs, it's normally in milliseconds. It's the milliseconds, so that's 15 seconds. Then it's gonna call after 15 seconds. It's gonna get it, get the task, get the results. Oh, this for loop here. So this program is just going to keep looping forever until something causes it to close. Get it. So this is just going to this is going to get whatever execution the C2 server wants. Get it. The task. So rule of the bit URL3 is going to be used after the task is executed to run. So we got the decryptor. So it gets it, puts it in a string it. So the commands are sleep, shell, implant, and quit. So yeah, it gets the command, but it also sends a response back at the end. We have this implant. Let's see what this implant is. Hmm, that's interesting. That's very interesting. This implant. So this implant allows it to download a certain file called spykit.exe, which is probably some more malicious program. So we got a encryptor and decryptor. We did look at that, but I assume that it's probably beyond the scope of this thing, but I guess it's just set to encrypt and decrypt information using a plain text string as a key. And there should be a key somewhere in here. IT. Hmm. All right. So it's using whatever IT is, most likely as an encryption and decryption key. Text to okay. Execute command. So when it executes the command, it should be called here. I think we skipped over it. All right. If it's not sleep, if it's not shell, So it executes the command. It puts the results in data 3 that it uses posted using URL 3, data 3, URL 3, just the results. So string 2. What did the posted return the reader? If flag, then break. So there is a way to break out this program. And that's if the C2 server returns a quit whenever it's reaching out to get their instructions. So if the task returns a quit, then it breaks out the loop. The infinite loop we saw here. Um, let's see. So we looked at that command.exe. It encrypts, it decrypts, building a malware execution pipeline. All right. Let's see if it mentions anything that I haven't. It gets a little bit more low level. Mhm. This is mostly like reviewing source code and try to understand what it's doing. I think we kind of gotta, let's see, copy that. Uh-oh. Where's my little copy paste thing with my Bob on the side? Huh, I guess I don't need it. What is the to submit is a post? What key is used to encrypt or decrypt? So we look, the encryptor took the plain text. It was it. It. It is program.get it URL to. That was for the encrypted, for the decryption. What is the first HTTP URL you visited? So it's this with oh, that didn't work. Copy, paste, reg. How many seconds is the hard coded value to stop? It was 15,000 milliseconds. So 15 seconds. What is the C2 command the attacker used to execute? That was shell. It was sleep, shell, implant, quit. Or the commands that this program will take from the C2. Was the domain used by the malware to download the other virus? That was part of the implant. It wants the domain. One thing I find curious is it says defanged, but these URLs and IPs are definitely not defanged. Normally, when something's defanged, it has the brackets around the dots. These definitely have big old fangs still left in them. And we're finished. This one was fairly easy, I think. If you're done any programming before, if you have not done any code reviews of programming, this looks like a great wealth of information that should probably be dug into. I'm not really going to dig too much into it because this is better to be read and take your time because not everybody's going to get it at the same time length or level. If there is something here you don't understand, my method is if I read something I don't understand it, Google search some of those times and find other sites that may explain it a little better until you find something that you like that starts to resonate within you. Um, that is pretty much it. Thanks for tuning in and have a great day. We'll catch you tomorrow.